So welcome, we want to look on matrix methods of solving systems of linear equations. There are so many methods we shall discuss. So the first method is the inverse method. So suppose you are given these equations and you are asked to solve for the unknowns. So here, the first step is to present them in a matrix form. So that is to write this form. So let this be our original matrix A. So the first step is for us to find the determinant of A, which is now found as 17. So what we use here is for us to eliminate this matrix so that we remain the unknowns on this left side. So the idea behind here is that if we multiply A by its inverse, we will have an identity matrix, which will just be like number 1, which does not have an effect on this side. So for us to remain with the unknowns on this side, we multiply by the inverse of A both sides. So therefore, we now proceed to finding the inverse of A. This is found by multiplying the reciprocal of its determinant by the adjoint of A. So we want now to find the adjoint of A. This is written as. So in finding this adjoint, two processes or steps are involved. Here we took the elements of the leading diagonal, we interchanged. Then the elements of the other diagonal, you change their signs. Well, so therefore we can write the inverse to be 1 over 17 times. So if we multiply this matrix times A, we will have an identity matrix of the form which is just like number 1. So therefore, if we multiply both sides by the inverse of the matrix, we will have so by this, then we will have x1 to be negative 2 and our x2 to be 4. So that is the matrix method. So let us now consider a system of 3 linear equations. So you are given these equations and you are asked to find the unknowns. So here also the first step is to represent them in the matrix form. That is here. So let this be our matrix A. So here, so therefore we can simplify this equation that x1 and x3 will be like we did when we were dealing with the two linear systems. If we multiply this matrix by its inverse, we'll have an identity matrix inside, which will be like 1. So this is what we will have. So our main aim now is to find the inverse of matrix A1. So we are going to find it step by step. So the first step is to determine the determinant of A. So determinant of A will be given by, so this is our A. So the determinant will be, so here you take 3, you multiply by the determinant of this matrix is here. Then you take minus 2 multiply by the determinant of this matrix. Then plus minus 1 multiply by the determinant of this matrix. So we find it as our determinant is 55. So that is step 1. Then, step 2 now is to find the cofactors of A and then find the matrix of the cofactors. So yeah, generally A is presented as, so it is matrix of the cofactors. C is written as, in which now we assign it is signed as so this is the matrix of the cofactors. It's represented. So each individual cofactor, for example, cofactor C11, second part, finding the determinant of the matrix left if we eliminate the column and the row of A11. So that is the same case with C12 is the determinant of the matrix left if we eliminate the column and the row of A12. So that is it up to the last cofactor C33, which is found by finding the determinant of this matrix left if we eliminate the column and the row of A33, which is this one. So now we want to find these three cofactors from our matrix A. The C11 is found by finding the determinant of this matrix, which is now so you take yes. Okay, so having found all the cofactors, we now write the matrix of the cofactors as C11 was 10, C12 was negative 10, so minus C12 10, C13 was minus 5, negative C21 will be 11, C22 will be minus 11, minus C23 will be C31 minus C32 and then C33. So this is the matrix of the cofactors of A. Yeah, so we now proceed to the third step, which is to find the transpose of the matrix of the cofactor C to find the adjoint. So if we find the matrix, if we find the transpose of this matrix, then we could now find the adjoint of matrix A. So the transpose of matrix C, which is written as T, is found by taking the elements of column 1 to be the elements of row 1 and the elements of column 2 to be the elements of row 2. So here, these elements becomes the elements of column 1. Then we take these elements to be the elements of column 2. These elements will be the elements of column 3. So this is the transpose of this matrix. So, and this is now our adjoint of matrix A. Well, so now we proceed to the fourth step. The fourth step now is to multiply the reciprocal of the determinant of A by the adjoint of A to find the inverse of A. So initially, we had to find out that determinant of A is 55. So now, and this is our adjoint matrix. So the inverse of matrix A will be 1. multiplied by this adjoint matrix. So if we now come to our initial question, we found out that the unknowns will be equal to the inverse of matrix A multiplied by this column matrix of constants. So therefore, you now rewrite it as x now this is now our equation. So let us simplify it. We now multiply this matrix by this matrix. It will be, so now therefore x1 is 3, x2 and x3. So that is the inverse method of solving a system of 3 linear equations. So this is it. So subscribe to our YouTube channel and continue learning on the other methods of solving systems of linear equations. So other matrix methods are in our videos in the channels. Subscribe, like, and watch the next video. Thank you for watching.